In this video, we're going to look at combining different types of surfaces in Rhino to build larger models. And I'm also going to cover some tips for generating images or representation of the surfaces that you model. I have basically generated a few compositions using this sort of profiling surfaces. So the first thing I'm going to do is kind of show you how you can actually customize the preview of Rhino. So some visualization techniques basically. So first thing we can do is I switch to parallel view here. You can also do that by going to view, set view, and select one of the isometric views. It could be either one of these, but let's go here. Something like this, and then you can see I have a dashed line layer, so I'm going to just hide it for now, and I have some profiling curves and surfaces as well. What if we wanted to bring the edges of these surfaces, like we wanted to see the overall surface geometry? So you can actually customize some of these features if you right click here, go to display options, and here basically you can enable surface edges, and that will bring in this type of display showing you the edges of the surfaces that are in the model. Now, if you're not happy with this thickness, you can actually customize them. If you go to objects and go all the way, let's see, we have to find surfaces. So under the surfaces tab, so this is the surface edge settings. I have it set to 4, but you can actually reduce it to 2 if you want. That will give a more lighter tone. You can also change the coloring of some of this. You can do, let me see, I switched to red, but if you want to see that, let me see how we can do that. There should be a way of overriding naked edges probably. Let's try to say that as well. Use objects color will be the object. Use single color with usage. Let's do 6. I guess this is kind of overlapping with some other control that I have. Maybe it has to do with the layer or the curves. So I'm just going to keep it as black for now, but you can control the thicknesses here. So you can go to just 2 or 4. Okay, then the next thing I want to show is I have these kind of bounding boxes, and one way of choosing the style for this could be using a different type of line. So you can go to line type here under layer options, and you can actually choose a different type of line type. For instance, we can use dashed for these boxes, and then you can also control the line weight here. So if you make it too light, they may not be visible. So if you want to see them, I'm actually making them a bit more thicker. And if you want to change, let's say, the type of the dashed line, the spacing of the dashed line, you can actually do set line type scale, and you can choose the lines here, and then let me see again, select objects, set line type scale, and let's say we want to enter 5. That actually changes the dashed size of the curves. So I can do 0.5 if you want to make it a bit more denser, and that way you can actually customize some of these default previews. And believe it or not, actually Rhino has a pretty good visualization in 3D and with the shadows as well. So you might just add these line thicknesses or dashed edges for your models. Now, what I want to show you is I'm going to actually build a larger entity out of these 2 modules. So what I'm going to do is I'm going to not just stack this on top of each other, but also find some sort of alignment that can help us connect these two groups. So the first thing I'm going to do is move one of the module on top and position them in relationship to the other, and then see if we can actually line them up in a way that we can connect them later. So let's see, what if we can actually connect them here this way, but this edge will be open. Another possibility could be that I can slide the second surface here and connect them this way. That's also a possibility. So either one would work, and you can be flexible with the way you're actually connecting these surfaces. So the goal is basically to do larger assemblies. Now we have certain things that line up. So basically I can simply extrude some of these edges downward to make connections. I'm going to turn off the dashed line for now. So let's say this kind of extends and connects here. If you get these sorts of artifacts, you can just explode the extrusion and then you can actually build connections. I'm going to keep doing this. Let's see where this leads. So I'm just pushing it down here. But what if we don't want to make it come down here, but like meet the surface right here, right? So something that maybe we can keep building on. So to do that, we can do extrude curve, choose this edge, and then you can do a direction. So I want to build this connection here. So I want to build from here to here. And then you can do set base point and push it all the way down here. So again, this needs to be, let's see, delete this edge. So that's the surface we built. I'm getting these sorts of artifacts because of the extrusion. Then you can actually grab this edge and push it down. Right, so that's basically a way of connecting different types of modules, but also essentially bridging between them. And we're going to do a lot more than just bridging, but basically what I want to show is also thinking about how to intersect surfaces and build different types of connections between them too. So one way of manipulating these surfaces is you can also use solid points. For instance, if you go to solid points here, you can turn on, let's say I want to bring or modify the edges of these surfaces here. I can choose all of them, turn on the solid points, and then go to wireframe and just choose using the solid marquee these points here. And now I can actually manipulate them, but there is some sort of an overlap too, which is not a problem actually. But you can just do set point, set Z, and then you can push it to a reference height. So set Z basically means I'm just overriding the Z value of these points. So I'm going to delete this edge. Maybe we can figure out another way of connecting them or lofting these edges. We can actually simply do explode ungroup. And maybe this goes here too. So one way of doing that would be to extend surface. So you can simply do extend surface, extend this edge, and then extend this other edge. And find the intersection here. So I'm going to delete this. We have to trim them. There are a bunch of ways we can do the trimming. You can just choose both of them and then trim that corner so that they could be joined. Right? Again, this could go up, I guess, one more level, or we can leave it as is. It's totally up to you. This is kind of an abstract exercise anyway. But there are different ways you can build these surfaces. So if I, for instance, extend the surface, this will extend any edge that I select. I can do extrude, right? So extrude will give me, I need to choose these edges at the bottom. And then I can extrude, but that will be another surface. Or you can choose these, turn the solid points on, or you can also use this move edge command Basically, the solid operations could be utilized to manipulate the surfaces. So I can again do set point, choose a reference here. All right. Now, what else do we want to do? We can actually use some of the features or groups that we have, right? So I can actually make copies here. And I can mirror this entity. Let's say we want to make it a bit more structurally rigid. So I can just make it into an assembly like this. Maybe position it at the bottom of this, right? So now I'm actually, they're kind of intersecting, but I can also use the gumball to flip the orientation or the rotation. And I can position the surface group anywhere I want. So I'm kind of lucky here because they're not intersecting, but in case they do, there are also ways of fixing that. For instance, let's say that we want to add this edge here, but it's going to intersect with the surface. So I can do extrude curve. So this is the curve I want to extrude. Actually, we can do extrude curve along curve. So I want to extrude this one, and this is the path I want to extrude it to. And you can see this is kind of intersecting with this other surface right there, right? So if you want to keep either one, you have to trim one of these surfaces. So for instance, I can simply do extend surface, extend this guy to kind of meet at the intersection. Well, if we want to be precise, then this can go further outward. And then I will just select these surfaces, go to visibility, isolate, and then operate here, right? How do we want to trim this? So one way we can trim it is by basically finding this intersection. So you can do intersect, select these surfaces, and then I will be able to extract these edges. And right now they're not allowing me to trim the surface. So what I need to do is extend these surfaces. So we first need to choose the boundary. The boundary will be the base surface. And then I can do a trim by selecting these edges and then trim that surface off, right? I can also do, again, another extend surface, push this inward, but we can also set a base point. So if this is my base point, I can find the perfect intersection there. So basically using tools like this, you can actually build or resolve these connections. Maybe here we can also add another type of like a diagonal line to make this connection resolved. But essentially, this could be like a technique of not only building connections, but also resolving intersections as well. Okay, so let's add a few more elements on this side. I'm going to grab onto, let's see, what portion can we get? I'm going to just choose this group here, make a copy, and then I'm going to flip the other direction, maybe delete this portion right here. Let's just keep it like that, and then just bring it in. Let's move it around. Maybe this kind of lines up here, and that could be like a portion of the connection, right? So if I open the dashed line, this is what we started with, but then we built these sorts of connections. And there is nothing dramatic here, but essentially we can also add more diagonal connections if we want this to have more structure. For instance, I can actually connect these two surfaces. Let's work on that. We can simply extract this edge. Let's isolate certain things as well. I'm going to isolate these surfaces, and I'm going to isolate these elements. So how do we connect these two groups? Well, we can also, like if this is an operation that requires this boundary, we can simply go select this boundary here and then do extrude curve. and then we need to choose a direction. So I want to go from here to here. Then I want to do set base point. So that will allow me to extend all the way here. And you will see that right now they are not resolving this intersection, right? So maybe I have to go not in that direction, but I have to follow the fold almost. So I can do direction, choose this point to this point, and then set base point, and then go all the way up here. So they kind of merge a lot better this way. Okay, so that's kind of the entity that I built. Now, what if we want to put some horizontal connections? How do we do those horizontal connections? Well, let's work on that next. So one strategy I would advise to do is to use clipping planes. So the clipping planes are basically planes that kind of filter the model. So you can actually move these using the gumball. You can move them up and down. And this will allow you to kind of cut the model at any location or position and see kind of the side that is being not filtered. So if you go to the properties of the clipping plane, you can see we have a direction. So I can, if I flip the direction, it will basically change these arrows, and this is the direction I'm looking at. So it's essentially just a section drawing tool, right? So this will give me very nice sections through the model so that we can actually have more precise control. And it will work on any plane. So you can actually do, if you hold shift, you can flip it in one of these planes, and you can actually also look at the sections of the models that you're drawing. We can also look at it the other way, the other direction, move it around, and kind of investigate the spaces that we are looking into. All right, so the next thing I would say is like, how do we, let's say, make a horizontal connection? So I'm just going to lower the clipping plane, and you want to eventually find these connections where you can actually define kind of the boundary of a slab or a surface. So one way of doing that would be to trace this outer boundary. So let's say we want to create a new layer, and this was actually in this layer, but that's fine. We can just name it as slab or slab contour. And then while that layer is active, you can come in here and then start tracing the edges that you will use to generate the slab. So I'm going here in this direction. So I'm first tracing these, right? So let's go this way. I'm going this way. So from here, I have a few options, right? If I go this way, it could be like, I need to go back at some point. So maybe I come in here, go this side, and then from here, I just close. So that could be like the boundary that I found inside of this position. So I'm going to do planar surface to define that surface. But what if we want to create one more at somewhere else, like in a height where we don't have a clear edge boundary, right? How do we do that? Well, to work on something like that, you need to switch to an orthographic view. So let's say we want to draw a section in this direction. Let's say this is, if you're working in feet, you want to draw a connection at this height. So I have this kind of reference line here. Let's see, it's showing, if I enable the projection, it's like at 23 feet. So maybe I want to draw this as a slab connection. So I'm just going to switch to wireframe, and then you can do project. So I want to project this curve onto these surfaces, and that will give me all the intersections of those surfaces, and you can just isolate them, switch to wireframe view, and then you can actually use them to develop the slab. So for instance, I can simply disable the project, go from here to here. Maybe this becomes kind of a segment, like a section of the surface. So we can build this separately, and maybe here there's something else, like maybe we go from here to here. So then I'm going to choose these edges, do planar surface. It's asking for Boolean processing, which is fine. As long as they're flat, I think we should be okay. So I built those two surfaces. And now I'm noticing like this is not actually enough space. So maybe this needs to move down a bit, right? Move down and enlarge. And then maybe then there's another way to get to that space. But essentially you can carry on doing this for other surfaces as well. So let's see, I think I deleted the clipping plane. Let's bring it back. All right, so this will go up. And let's find another place. We can actually go to the rendered view, and I'm going to move it up. This will be easy probably to determine the spaces here. And here maybe we deploy a few of these surfaces too. So let's say that we go to the side view. And then here I want to draw some more lines. So for instance, what if we have a 12 or 15 feet height here? Go this way. Then copy again to another 15 feet, another 15 feet. So these could be the regions, but I would kind of suggest you to find the heights that match the folds of the surfaces. That seems to be the best approach. Okay, then I can do project. So I project these onto all of these surfaces. And that gives me essentially these intersections, right? So from these, I can build the slabs or the horizontal connections I want. So maybe some of these actually follow these sorts of orthogonal directions, or maybe we can also extend some of these curves to match each other. Like this didn't perfectly match, but it could be like a way of building these surfaces. So maybe I go here. And then here I'm thinking maybe we do something like this, right? So I will just select trim everything else. Since we don't need these lines, these were used to construct the slabs that we have. And then I can do planar surface. Let's do something different for this part. I'm going to go from here to here, and then from here to here. Let's see, this doesn't perfectly line up, but it's okay. I mean, it's at least will give us some surface. Right, so that will be another planar surface. So let's do show, and we are basically building not just vertical elements, but also horizontal connections that kind of help us build the massing, right? So I'm just going to choose everything, do select curve. That will select all the curves. You can simply delete them if you want to clean up the model a bit. Then you can choose them and switch their layer to be the default layer so they all share the same visibility. Now there's an issue here, right? So this is not touching our surface. So what we can do is extend the surface. So this can simply be extended. And this might also be okay to find kind of a resolution here, right? So how do we intersect these elements? For instance, you can do intersect, and then you can do extend. So I want to extend this curve to the boundary, and then you can do a trim, and then trim this edge, and delete the edges. I can do select curve again, and delete, and show. So that basically helped me to merge it with these surfaces by extending, and then I was able to trim those edges, right? So it's basically like these tools allow us to have control over how surfaces meet as much as how we can think about building them. Now, if you feel comfortable with making this into a larger model, maybe you get to something like this. And in this one, I don't have any slabs necessarily, but I can show you the same techniques could be employed here. So if I do another clipping plane, I can actually find any type of location or connection. We can also do it in the side view or section view. And then you can build surfaces here in these pockets. So for instance, let's look at it from the side view. So let's say we want to use this as like a ground or like a level for a slab. Then let's say I want to offset it down by 15 feet. And above 15 feet, maybe we do it a few more times. I'll just show you. I can just project all of these curves and then find these intersections and kind of take it from there, right? I can just choose one of the layers, isolate them, and you can just work on building the slabs in these connections. So basically, let's switch to wireframe mode. So if I want to build something here, I can simply go here and here. Maybe this becomes kind of construction. So since it has to be a closed boundary, just choose all of these. This looks a bit weird, so let's do a fillet. Maybe it's not. Let's see, fillet, and I want to do join and trim this edge to this edge. Well, that didn't work, but it's okay. We can just simply extend and then do a trim. Right, so the more you do, the faster you would get with these sorts of operations, and then you can always check what you're building, where you're building. So that one is like in a close pocket, but I have some like surfaces here or some spaces that are going vertical, right? So that could be used essentially. Maybe we do build one here on this level or a few. So let's choose these. So how do we build them? Well, from here, maybe we go in, so you can do extend. You can follow some of these lines. And from here, maybe we do another extend. You go this way, and then to this, I go from here, right? So it could give me like a construction. And I have a few overlapping lines here, but that's kind of okay. Maybe this is actually like a larger group of surfaces that we can connect. So maybe this goes here, and these go from here to here. And I'm just going to connect this guy perpendicularly, right? So this has a lot of line thickness, so let's fix that. So I'm just going to go back to the layer. And then make this into a hairline. I think that will help me see this a lot better. All right. So this needs to be cleaned up a bit, but I'll just do extend and trim. So if this is going to be one surface, one slab, we don't need these, right? So essentially it needs to be like a clean boundary that we can get the surface out of. And I'm just wondering if it will make this into a planar surface as well. It can actually, like it just does it through Boolean processing, right? So it can actually take in a network of curves and give you a surface connection between them. And that's essentially it. So I was able to connect define these like surfaces here, some sort of connections, and that could basically work towards building more connections in a larger volume as well. All right, so the last step I want to show you is you can actually export some of this as images. So let's look at the dash lines. I'm actually going to do, let's clean this up. So I'm not going to do the rest, but I think you'll be able to kind of follow these techniques to kind of use in your models to make new connections if you want. Some of these curves I think could help us. The others, like maybe these dash lines, we can also use. So let's say we do extend here as well. So maybe I have these sorts of volumes kind of representing the larger assembly. And then if you want to export this in any way, there are a bunch of techniques we can use. For instance, you can again set to like an isometric view. And let's zoom in to this. So let's say you want to show the inside, the interior of this model. You can simply do a clipping plane and position the clipping plane in a way that we can also see these spaces, right? So let's say this is the image you want to capture. What you can do is go to display options, and you can also give a line thickness to the clipping plane. So if you go to rendered view and go all the way to general, objects, all the way down, there's clipping plane objects, and we should have, let's see, this edge thickness is, I think, controlling where you're cutting, right? So this is, I mean, we can give this kind of a thick value so that we can differentiate what is being cut from what is being seen. So this could be like a very pragmatic, easy way to differentiate these like visible geometries and the cut geometries. So if you want to export this, you can do ViewCapture to file. And you can do this with transparent background. A PNG file wouldn't have the background, so you can actually bring it into Illustrator, include figures or other things on it. And you can increase the resolution. So if you do the viewport, that may be lower in resolution, but then you want to do custom, lock the aspect ratio, and maybe increase this resolution. And then when you do apply, you give it a name. Let's see if it executed. So I'm going to do again, ViewCapture, apply. Oh, it should be there. Let's see. There it is. Well, I actually had, let's try it again. ViewCapture. Okay, scale. Okay, that's kind of scaling it up. Let's do viewport. Apply. Let's do 2. Well, this kind of works actually. So this is an image with a transparent background, right? So you'll be able to kind of use this, and you can deploy multiple of these and spread them as an isometric drawing. For instance, if I go back to the clipping plane, what you can do is you can flip this to the other direction and then make an image of this and then separate them in the vertical direction, right? So I can simply show you how to do that too. So basically you can have two PNGs that will fit on top of each other, but you can actually spread them out apart using additional line drawings as well. So you can do ViewCapture to this too. Let's give this a name like 2. Actually, we need to do 1. We need to do one more. Let's do this one as ViewCapture to file. Let's do this as, let's replace 1. All right, so that's basically it. this is the first one, this is the second one, and that could fit on top of it in Illustrator, right? So that you can also do. And you can also use these as like an overall representation of your models. And again, there are a lot of things you could try out. You can change the line types, print widths, line type scales on how you want these to be represented. Also, you can go to display options, give some control over how you want to render the clipping plane or cut objects, how you want the surface edges to be visualized. So those are the areas you can look into. And for everything else, you can basically think about connecting these surfaces by building bridging connections. And for the slab definitions, I implemented two things. One of them was like using clipping plane to look at section profiles, right? So you can go inside this model and find where the slab needs to be and draw the boundary. The other one would be to draw in section a line and then project it onto all the surfaces so that you can extract the edges. Yeah, so I hope this is helpful moving forward, so you can use some of these techniques and work on the 3D modeling. And if you have any questions, let me know in the comments below, and I'll see you in another tutorial.